Okay, Defn, episode 8. Ray McDermott here in Belgium. Vijay Carin over in Holland. How are you doing, Vijay?
Hi Ray, I'm doing pretty good. We had a pretty decent weekend with, I think we had fireworks nearby, so we enjoyed it a lot. And today I'm having some bit of a lisp because I just bit my tongue and I was bleeding for half an hour and now I'm putting some ice and it's going to be lispy. So
the things you do for love, the things you do for this podcast. I mean, I think it's impressive. I think you'll be. I must do it myself next week. Yeah.
We keep cutting our tongues every now and then.
Yeah, well, I try and bite my tongue, but it's very difficult.
Yeah, but anyway, the first of all, I'd like to thank our listeners. We have around almost 1,000 people listening to the podcast.
That's fantastic, isn't it? I mean, we it's exceeding our expectations, especially that it's sticking with it. We're sticking with it. I think it must be the fact we're having a lot of guests. I can only imagine that's the reason why people are actually bothering with us.
Of course, otherwise in a couple of episodes they'll stop listening and they're like, oh God, we can't take these guys anymore. Especially our self-deprecating humor. But in any case, I mean, we were very fortunate to have all these guests, and we are lining up some other interesting guests in the upcoming episodes. So hopefully we'll have very interesting discussions with a lot of topics in Clojure. So stay tuned.
Yeah, well, I think it's still, there's so many topics, aren't there? So much innovation going on. It's actually, you're trying to cherry pick at this moment. There's so many things to talk about. Obviously, we're going to talk a little bit about a few of these things in the news now, but just at a general innovation level, I think it's still true that Clojure is still the king of innovation as far as computing is concerned. I still feel, I don't know about you, I still feel like whenever I fire up Clojure, I still feel like I'm at a kind of... at an innovative place, at a leading edge, at a place where things are still evolving, that I'm still learning a lot every day. Every time I open up code, I'm learning something new.
Yeah, for me, of course, I completely agree with you. It's like a cutting edge stuff and well, not completely cutting, but, very interesting things happening, especially on the front end, on the back end, and with specs and all that stuff, and distributed computing.
Yes.
We're clearly on the forefront. And the advantage with the podcast for me is that we get to talk to these amazing people, and we're just learning from them. And this is like a free coaching session.
Yes, so it's excellent, yes. The other thing as well, that I think is really interesting about Clojure, actually, is that despite the fact that there's a lot of, and maybe it's because of the Lisp aspect of this, but despite the fact that there's a lot of innovation around the community and in the core as well, it's still remarkably consistent and stable. And, you don't feel like you're having to, rethink everything every time a new innovation comes on. It seems like it's often, most of the innovations are very, let's say, sympathetic to the overall concepts behind Clojure, and those core concepts seem to be bringing around that innovation. I think that's really a phenomenal thing, and we all bow down to the Hickey. The guy made a lot of good choices.
Where does he live, by the way? Somewhere in Colorado or something? I don't know.
I have no idea, but don't stalk him, okay?
No. I'm just thinking every now and then, whenever you open Emacs or something, and then you just turn towards that side and then bow down in respect.
All right, okay.
Okay, that'll be really, fundamentalist, but let's not do that.
That's for future generations, that one. Yeah.
Exactly. But anyway, our first segment of the podcast, news and events. So what is happening? First of all, Euroclojure, the talks are announced, and the lineup is fantastic. Of course, without me, because my talk got rejected.
Oh,
Too
man.
sad.
Let's just talk about that, because this is harsh. Yeah, and you were gonna.
I could have kick-assed it, but anyway, never mind.
Actually, I believe they have this model for accepting and rejecting talks, don't they? That's all about awesomeness. Obviously, they fucked up. They screwed up this time, big time. Yeah.
But anyway, it's I can imagine it's a couple of days talks, but there are fantastic lineup already. David Nolen is coming and Carin Meier, and there are a couple of very interesting talks that I see already, especially with the big data stuff. Not big data, but Dragon, or I'm sorry if I'm pronouncing his name correctly or not, but he's working on this Neanderthal, the GPU-based library that I'm really excited about.
Right, yes.
So, and there are other fancy talks with Docker and one more talk about spec. But in any case, I'd encourage everybody to take a look at the speaker lineup, and of course, we will be there.
We will.
Yes. So by hook or crook, I'm going to give my Onyx talk. I'll be standing outside, like back in the, I think, Roman days or Greek days, shouting, "Hey, Onyx is awesome," and then giving pamphlets away.
Like the street corner prophet. Yeah.
Exactly.
Well, we're going to do a meetup, aren't we? We're going to start organising this soon. We'll do a meetup as well. I've got a few things planned as well, so we'll have something good at that meetup. That's for sure. Yeah.
Yeah. Speaking of Onyx, Onyx got funding. That is a big news this week or last week.
Yeah, that's ridiculous. Yeah, these guys are. I mean, we've talked about how incredible their vision is, also, and I think it's fantastic news.
Yeah, it's amazing, and they're teasing us a bit, especially on Slack. I think Michael and Lucas are teasing the kind of product that they're working on, and they want to give some sneak peek pretty soon. So we are pretty excited, and hopefully Mike or Lucas will join in our podcast, and then we can pick their brains a bit and maybe get a peek into their future plans. We'll see.
Yeah, well, I mean, I must admit, I'm about to get started on some big data distributed processing, and I'm looking forward to it because this is something which is going to go on for quite a few months, even years. So I really would like to get their vision, because I think, given where it is so far, I think it's very, very promising. And they've already got a lot of the fundamentals spot on, I think. And again, it's very close to that data first vision, and that and we'll come on to the kind of Clojure at scale stuff in this episode. But I think they've got very many things right there. Obviously, there are whenever you go up to scale, you've got all these tooling issues. So I'm sure that's what they're kind of working on. But great news to them. Congratulations to them. They're obviously they've worked really hard. They've put a lot of their skin in the game, and so all congratulations. And I'm sure they're going to do an awesome work. Yeah, and great luck. Yeah.
Yeah. And I think I just read on Twitter that Reframe has a new version available. Reframe, the reagent-based framework, and this is probably one of the most awesome readmes ever on a GitHub page.
The tutorial, is incredible, isn't it?
It's pretty awesome to read. So I haven't seen what's new in that yet, but that is something that I would like to mention.
I think the guys from Reframe have just got to be careful that they avoid Misha launching the nukes.
Yeah, that's true.
Okay,
but,
sorry. Yeah.
Anyway, that's Reframe, and Ambrose was the core-typed developer. He has been chugging along nicely, I suppose, and he's now just announced a small project for automatic annotations in Clojure spec. There was an Indiegogo Kickstarter. You can't call it Kickstarter because it's Indiegogo now. Oh, crowdfunding. Yeah.
Crowdfunding, yeah.
Crowdfunding campaign. Unfortunately, it didn't reach the target. I don't know, but how it is going to affect. But I'm really curious what he's working on, and we should see some interesting things coming out from him soon. And he's another target for us to bring onto the podcast.
Definitely, yes.
Yeah.
Very interesting work he's done so far on the core type stuff, also on the logic stuff as well.
Yeah. Okay, so let's get on to the main discussion for today. So this is episode, as you can, as our audience can imagine, we don't have any guests in this episode, so we're gonna put our ignorance out there.
It's the village idiots once again.
Yes. So today we want to talk about Clojure at scale. It's always a interesting discussion around this, because most of the people keep complaining or worried about how it is going to scale in terms of code, in terms of how do you manage large code bases in dynamic languages, especially how do you design large-scale programs in functional programming, and other issues like distributions and the team sizes. all sorts of stuff.
All right.
So the first thing that, well, I started with object-oriented programming. There was a bit of a Pascal in my life at some point, which I don't want to talk about.
Did you really start with OOP? It didn't come in before that? I mean,
No, I was doing Pascal first, and I did some COBOL as well, but that is only during the university. And I used to learn and teach COBOL simultaneously, so that must be spectacularly painful for my pupils.
Jesus. Wow. Yeah.
So that is learn by teaching method.
I think I wrote one COBOL program and that was it. That was enough for me. But like you, yeah, I did Pascal as well. But I spent many years as a C programmer actually. So I was doing that for a long time.
Yeah.
But anyway, so you mostly started with OOP. But you're younger than me anyway, so you know.
Yeah, I'm not sure though, but maybe. So I did start with a bit of Pascal, and then a bit of Delphi, and then first commercial stuff was in C++, the Windows programming, the horrible HWND to something and that shit, MFC and Windows programming. So that was completely object-oriented thing, and then I started doing a bit of a Java back in 1.1. AWT, and it quickly turned to 1.2, and one of the interesting books that I read during that time was Bruce Eccles' Thinking in Java. He had Thinking in C++ as well, I think.
Yes.
So designing large-scale programs and designing bigger programs, I always started thinking in terms of object-orientedness. So first you think about what kind of classes that I need and what kind of actions I need, and pretty much all the program design was guided by the language that I'm using, which was Java. So then we had UML and object-oriented analysis and design. So that's how I got into large-scale programming, I would say. And I think one of the biggest programs that I ever wrote, well, not me, but essentially with a team of 6 other people, that was for... I think advertising management for Quark some time ago. So when you design a large-scale program, those are mostly driven by the language that you're using.
Well, I want to, sort of, but I want to sort of pick up on that a little bit. Let's maybe just go back a little bit, like the Clojure way, of defining the problem. So kind of like, what do we think scaling is actually? What do we actually mean by scaling? Because I think you mentioned a few kind of metrics there, like team size and stuff like this. But in terms of design, what do you think about scaling? Because I tend to think of scaling as sort of in a number of dimensions. Like you can think about, well, how big is the problem that you're trying to address? And sometimes a relatively small problem can still have a big code base, because I don't know if you've seen how many to-do list goddamn things out there. But apparently this is a big problem. It needs a lot of solutions. And I'm not just joking about that, because obviously the Node frameworks do a to-do list as a sort of jokey.
I think make a to-do list app is on everybody's to-do list now.
Yes. 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 Yeah. That was nice. Bit of recursion there. Yeah, we'll come back to that one. Yeah. But what I was thinking was that actually people complain, don't they, about we made this to-do list. But actually, our framework is so nice and so wonderful that this to-do list only shows off like 10% of its features. But anyway, so it doesn't matter. What I'm trying to say is, well, or maybe it does matter because that's kind of the size of the problem. That people say, okay, well, if you've got a small problem, then you can kind of just do it from code with one person out of your head. If the problem gets bigger, then you need something to constrain that, something where you can make some decisions. So that's what I'm wondering about. I'm wondering about what are the actual things that, because what things actually do you flex on? What are the decision points that you need to make when you want to scale something? Because I often hear this from framework authors that, the reason why we did a framework was because you've got too many decisions to make, you've got too many choices. And I wonder what you thought about that, because I think that seems to be the beginning of it, or the heart of it, is that we're essentially just, we're kind of rinse repeating this problem. So in order to kind of to scale it out, if you like, well, we just put a framework together, or we put some kind of application server together, or some other kind of big lump of stuff like an ERP system, or and I find that a really interesting discussion point. Actually, I know we're just starting this, but let's think about that. Let's have a chat about that. So where are we talking about on a scaling here? Like, we're talking about a to-do list. We're talking about a web application. We're talking about a whole line of business application.
Well, I think the most common thing these days is the web applications, right? So when I say scale, at least in my viewpoint, the major thing is that how do I design a big application, or an application that has a lot of use cases and everything, and how do I start? Because when I switched from Java to Clojure, or first time when I picked up Clojure, because I'm so used to this, the first thing that I do is class, person, and then just create a class, and then think about what is the model layer, and then design the whole model layer, and then the data access objects or data transfer objects, and these kind of things, all this ceremony. Whenever I'm starting in new applications, because I thought web applications are most common thing these days. So if we start with an application, I'm thinking about all the classes, data model.
Can I just stop you there, though? Because does the phrase web application mean anything anymore?
Well, nowadays I don't know what the difference is anymore, but obviously if you're building desktop or any kind of large applications.
No, what I mean by that is that if you're doing like an ERP system or a CRM system or whatever system, it's always going to be a web application. So it's kind of like a given interface on the server side, isn't it?
Yeah, of course.
But anyway, so you're right. Let's say some big server application, because like where I work, the big ones are things like ERP, CRM, all these kind of e-commerce style applications as well. Yeah. So you have e-commerce platforms, CRM platforms. I mean, I think those are big things which you need to scale, aren't they? Because there's a lot of use cases, like you say, around, well, how do I manage the product catalog? How do I manage the content? How do I do the inventory? Blah blah blah.
Yeah, I mean, I'm not saying that web applications are a bit different when you're designing, because I worked for building desktop applications that are fairly complex for clinical trials and stuff.
Sure.
So that is pretty, for the big pharmaceutical companies. That was built in Java and Swing and those kind of things. So, but the thinking behind building this application, that is fairly similar, right? I mean, you start with thinking about how I'm going to design my model layer, and how I'm going to design my data access layer and data transfer objects and all sorts of stuff on the front end. So the thinking is so much tied to object-orientedness. Now,
do you think that's true, though? Because I maybe I'm just old school, but I always think like the beginning of this stuff is talking about user stories and talking about what's the data actually, and then as soon as you get the programmers involved, they start talking about all these classes and stuff. But the actual beginning of the design process of what are we going to do, it's mostly about, well, what data do we want to capture about the customer? What we're trying to sell these products. We're trying to or do this thing, whatever this thing is. And then it starts to go into the thing you're talking about.
Yeah, of course. I mean, I'm not talking about the functional side of it, but once we move to the technical side of it, then we end up with all these discussions. And anyway, the biggest conceptual jump that I had to make when I started with Clojure is that, okay, how do I start? What is the first step? Because it was just a function, and then I write a couple of functions in a namespace. Is it done? So with that knowledge, when I made my first application, I think it was around 1,000 lines of code for generating PDFs or something in Clojure.
Okay.
And that was pretty okay. It worked. And obviously, like everybody else, I'd love tests, but I didn't write any of them.
You had this 1,000 lines in the REPL you had to load up every time.
Yeah, it's more or less like that, but saved into a file.
Yeah, okay.
but later, of course, it's divided into multiple namespaces because you want to separate similar functions together into different places. It's not a large code base, but one of the problems with my code that I saw is that after 3 months or something, I go back to the code. Now I'm completely lost because there was no spec, there was no schema, there was no. Every function seems to take a map and give a map, and
Okay.
I was super confused. Like maybe it's just my stupidity, obviously, but it took some time for me to remember what happened. That's what I mean by scaling it up. Now, if I imagine the project being worked on by multiple programmers, so how do you communicate the intent? How do you communicate these things? There is documentation, obviously. These are all standard problems. So that is one kind of scaling that I'm really interested in, how large Clojure programs are large any other functional programming things.
Well, maybe it's what you're getting at here is that, and again, it's a very interesting thing, is that with functional programming, we tend to be doing these like you say, these functions that take a map, give back a map, whatever, or take a function, give back a function. However, we're going to do these things. And I think what's confusing about it potentially is the fact that the data that's going to be piped through these functions is not there. Whereas with the object-oriented model, you're essentially putting the data shape and the data model concretely into your programs, aren't you?
Yeah.
And that's maybe the biggest mind switch, like you say, is how do you rid yourself of this desire to constantly want to enforce a rigid shape on the program itself and to have that visibility.
Yeah. Yeah, and also the whole data modeling thing, because I think the book by Alex Miller and I forgot other author's name, I apologize. There is Clojure Applied, and the very, very nice book, by the way. I'd really recommend it. And they start with the data modeling and then giving you strategies of how do you model the data, because obviously data is the king in the Clojure world, or queen, depending on how you see. So Her Majesty the data, you need to treat it how you're going to model it. So they have some discussions about whether it is going to be a map or a record, or when do you go for records versus maps. So that is something I think. Records versus maps is one of the fundamental decisions that you need to make when you're starting up a large-scale Clojure program.
What do you think about but what do you think about that then? I mean, I know we've got differing opinions potentially in the community about it, but I see these def records and all these kind of things as generally pretty annoying. Actually, I prefer the maps personally.
I mean, maps are very, very, very flexible, right? I mean, that is the entire nicety of using maps. But the records are going to give you some sort of, kind of an communication of your intent. Like, okay, I have to have these things. And the nice thing is that you have these helper functions that are automatically generated for a record. So you can always use maps versus records. And also, I think there is a kind of a performance benefit as well if you're using records, because they're backed by a proper Java class in the backend instead of a hash map compared to maps.
Don't say that. Don't say it's a performance benefit. No. I mean, that's a desperate measure, that, isn't it? It's like, we're going to get 1 nanosecond throughut better for a type versus a map.
Of course.
That's the last bastion of optimization.
That's true. But at the same time, we need to. The major advantage is that you have a specific structure, and you know which keys are there, and that is the kind of thing. And on the other hand, you have less flexibility. So you cannot just add whatever the keys you want. Of course, if you add a new key to the record, then it will be an additional map inside the record.
Well, I'll give you an example of where I, for instance, concretely wanted to do this. Is if you want to persist data and then read it somewhere else, as soon as you put it into records, or Java classes or whatever, it becomes an absolute nightmare. in my opinion, because you have to then, on the other side, on the reader of these things has to understand that object existed, that record existed, and that is essentially poisoning the data. Now, if you happen to be the one that's reading and writing all the time, no problem. Of course you can do that. But if you're ever going to share that data, or if the intention is ever to put that data on the wire for somebody else, then putting objects around it is just the worst thing you can do.
Yeah, that's true. But that is the. I think that the chapter also talks about the same stuff as well. Like the flexibility that you get using the maps is essentially what you're pointing out. That is the advantage. So you can just you can safely transmit the data between different systems, and there is no additional type that you need to know to read this one back. So that is one of the things. Anyway, so that is about the designing the data, and the second thing when you're writing larger Clojure programs is how do you come up with the different layers? Or that's a big word probably, but how do you organize the code? The only logical way of organizing the code in Clojure is the namespace.
Okay.
So there is no other higher level module, or I don't know what is the right word for it though.
Well, let's say this
compilation unit.
Yeah, I know, but somehow you can think of it as namespaces are good because you can think of it as a distribution model, can't you? If it's a way of just doing the things that object-oriented thing that is good, which is to separate function A into a namespace. That's obviously a good thing, isn't it? If you're talking about like naming problems, that's how you solve that, isn't it? Essentially.
Yeah.
But I think we talked about this before, didn't we? But you have to get this kind of org.clojure.com.core thing. In order, it's reverse domain name stuff to do that. And if you're not careful, if you just pick up random names, then you're bound to have this. What's that? The thing in Node, the left pad problem.
Yeah.
So.
But I think
doesn't exactly get you out of jail,
Yeah, but we here I think in the Clojure world we're a bit lucky because we're piggybacking on JVM stuff, and there is some sort of a convention there already, and everybody kind of agrees on that one. So I haven't seen anybody saying, okay, I'm going to use the same package name like everybody else.
Well, no, it does matter. I mean, we had this problem. We had a sort of bug or a kind of funky thing at work recently where there was a library, a Java library that was JDOM. So we all know the old JDOM library.
Yeah.
So obviously to take things from XML and put it back into XML, etc. And this is all fine, but they changed their name from, they used to have a library in the Maven, it was JDOM/JDOM, that the organization was JDOM and the artifact was JDOM. And then they changed it to the organization, or the group, being org.jdom, and then the artifact being jdom. And that caused all kinds of problems because, then all of our dependencies got a bit messed up and we had different, the jdom was the same thing and it got everything, the class path was messed up. And we ended up having a production bug through this. And it's like, people have their heads, a lot of head scratching. Why did they change this? So you have to be careful. You're right. There are conventions, but even in the Java world, people don't always follow them. And then, because of that, then they catch up later. But not all of their consumers, are aware of that. So I'm just saying, that it's we're certainly not living in a perfect world. And I think,
of course, this is something that is a problem in every ecosystem. How do you manage packages? How do you share code?
Yeah.
So I think a couple of days ago I was talking to one of my colleagues. Like, okay, this has been a big issue for every language and every community. How do you share code with each other? So that's something, at least in Java world, I think there is some level of sanity already established. Of course, we have all these transitive dependency issues and all the crap, but still slightly better than just pulling random scripts from the outside and running them. So anyway, so coming back to the object-oriented thing, I think one of the interesting things with object-oriented programming is that the design patterns, right? I mean, that has been one of the biggest things people still learn, how to organize their code or how to think about the problems, how to solve common issues. So in functional programming, because there are so many problems that are not there, so there is no equivalent patterns in functional programming. The only patterns that you see are the functor or applicatives and these kind of things. But you don't see similar ones like creational patterns or behavioral patterns. So I was
monad.
Of course, the monad.
Oh, Jesus, the monad. Yeah. Once you know it, you can never explain it. I love those things.
It's maybe we should try to explain monad in one of the episodes.
Yeah, not now. We should have a drink first, I think.
Yeah, that's true.
Maybe that should be the subject of the Defn meetup, Let's all just get drunk and explain monads and record it for posterity,
Yeah. I think we should talk about all sorts of monads, like the free monads and the state monad and all the stuff, and that'll be cool. But anyway, let's not.
All right, but you're right. But you're right. There are kind of like it's a different order or a different thinking of patterns, isn't it? Because all of those patterns, if you remember the sort of Gang of Four book, they were the funny thing about the history of that book. I don't know. I kind of was fascinated by that book, so I did actually read it. No, you wouldn't do it these days. You wouldn't read a book these days, But of course, I did.
The only book that I read is the How to Copy Paste from Stack Overflow.
Yeah.
So there is actually
that's a short book, that one.
Yeah, because there was the I am developer Twitter account. That guy tweets all this fake O'Reilly.
Yeah, I like it. Yeah.
So he tweeted this how to copy paste from Stack Overflow, and somebody went ahead and actually wrote a book of 10 pages with licensing issues and how do you copy paste and how to give attributions. There is a Git book, by the way. Anyway, so
okay, yeah, but so
Gang of Four book.
Yeah,
yes.
so and the history of it is a little bit that the authors, they were experienced authors themselves, obviously, but they also went round and talked to a lot of good programmers where people had success, and they tried to say, okay, well, since you've had success, what kind of tricks of the trade do you have that you can try and teach us? And while they were doing this, they were cataloguing all of these practices, these so-called best practices, and they realised that certain of these best practices were common amongst a lot of these people. And it comes back to what you said at the very beginning, actually, VJ, is that a lot of them are rooted in the language environments, and they ended up being hacks or tricks that they used to get to a particular endpoint in the language that they were I'm going to say suffering, but let's say they were working in,
Yeah, but the one of the things that I wanted to mention was Peter Norvig had a small presentation about how to actually write these or do the same kind of things that you do with the design patterns and translate them into a dynamic language like Lisp. We'll post the link in the show notes, by the way. So there are some patterns that have no meaning in functional world. For example, all these creational patterns, because there is no new in Clojure, right? I mean, there is no you're not constantly creating new objects. Of course, when you're interoperating with Java, then probably there is
back to your def record again, dude.
Yeah. But there is an instance, and there is, of course, you can treat that as a factory. But most of the patterns they don't need. You don't have the same problems here. You have different kind of problems. So that's why you have these monads and all that crap, and all the shiny stuff, I should say.
Well, a lot of it, like you say, is creation, and then it's how do you iterate over things, and how do you change things. So you're absolutely right, because there are essentially three things that that really hurt your head when you don't do them anymore. You know, I remember somebody at work was asking me the other day. He says, "I can see why you guys. There's a lot of you guys. You know, guys. He was from another vendor. He was from a vendor, in fact. And he was saying, "Oh, the guys at our place, they love functional programming. I know you love functional programming. But you know, and I just don't get it. You know, what's the big deal? You know?" And I was saying, well, if you try and think that you can program in a language without variables. You know, try and think about that, because that's a big difference. That is something which non-programmers can kind of try and understand a little bit. It's a difficult mind shift, isn't it? Because if you don't have variables, then all of these design patterns are a bit meaningless, aren't they?
Yeah, of course. I mean, I think that another way to say it, like, just think about without assignment. There is no change of values, so that you can't constantly assign new values to the thing. But that's an interesting thought, by the way. Yeah.
But there are assignments, aren't there? You can say let something be something. So
yeah, but that's just a binding. So that's not assignment as in the equal operator in the mathematics, right? You just say, okay, now I'm going to have this value, and then it is going to change after some time. So
the change part is separate. Yeah, obviously.
Yeah. So that's the interesting part. Anyway, so coming back to the architecture of large-scale applications, so I think Stuart Sierra is the guy, right, who made the component.
He made component, yes.
Yeah. So that is one way to look at or organize your code. I think there is a lot of support in the community to use a component. I know a lot of people who are using component. I tried using it one time, but I felt somehow it didn't fit. Maybe I didn't spend enough time with it. So
I think the thing about component is that, again, it's maybe one of these things where let's be honest, we're not writing, well, you're writing 1,000-line Clojure programs, but we're not writing ERP systems in Clojure.
Yeah.
Whereas if you're the guys at Walmart, they were saying they used it to sort of commonize their model for continuous integration and for these kind of things. And I think you need certain common patterns that the team will follow for how do you build your code and how do you test your code, how do you bootstrap your code. And I think those are the kind of things that the component is aimed at, isn't it? I think there's a bit of a scope creep in some respects on that thing. But I think the concept of being able to organize your code and the building of your code and how do you bootstrap your application? Because that to me is what that program is there for. It's to say, how do I start my server? You know? And that's definitely a very, very laudable and decent and proper thing to want to do. To commonize that aspect.
Yeah, and also the dependencies between different modules. Right? You have
it's a sort of orchestration style thing, isn't it?
Exactly. Yeah. So that is something that I think that's the reason why community adopted component, because everybody was trying in their own way how to solve this problem. Because of course you have the modules, and I have this I should call namespaces. So I have a database namespace, I have a web server namespace, I have templates namespace, I have mailing namespace in my application.
Yeah.
I have all these things, but there is an interdependency between them. How do I manage them? How do I arrange them? And how do I specify that this layer requires the other one? The visibility. So when the code starts to grow bigger and bigger, these are going to be bigger challenges. So component is probably one of the interesting ways to organize your code. But
we call that architecture,
Yeah.
That's funny, isn't it? That's funny to think that it's like the ISO 7-layer model, and
end to your architecture.
Oh God, I mean, and you get some of these Java things where everything has to have an interface and an implementation, and you have 7 layers with three interfaces and 3 classes. Well, it's only one line of code, for God's sake, And so we can go crazy on this stuff, and thankfully we don't do that in Clojure,
Yeah, of course. By the way, speaking of architecture, there is I think an open source book or something. There is a book called the architecture of open source applications. I think it is available online.
Okay.
It's a very fantastic book because there are lots of very, very smart programmers explaining how they built large systems, like people who built LLVM, people who built Hadoop, and Eclipse. Okay.
Well, it's still a big program that a lot of people use. I mean, you know.
Yeah.
I'm not a fan of it as I've used it for a few years, but I'm honestly, I'm more of a IntelliJ user anyway. But you know, it's definitely a complicated program. That's for sure.
Of course.
You know.
I mean, I built RCP applications on top of Eclipse. Eclipse framework.
Right. Yeah.
Desktop applications, and I've seen the hell. And I came back.
But what are we talking about here? We're talking about we should put the link to that book in the show notes because I definitely would like to have a quick glance at that.
Yeah.
But you're right. I mean, in the object-oriented world, you know, it tends to be front-loaded with all this stuff, and of course if you go back to the sort of Java, the Java Enterprise Edition. That was all load of blueprints and patterns, like you were saying.
Yes.
Well, you know, we laugh at them now, but it's kind of like, you know, there is something that we want as humans. You know, I see this a lot at work where, you know, we want a kind of template. We want some guidance. We want a bit of leadership or a bit of vision. You know, having a kind of free for all is scary to many people. You know, some people really want that. Other people would rather have a kind of everything laid up for them, you know, and served with a golden spoon in their mouth.
I mean, there need to be a right balance, right? Because you don't want to have complete free range stuff. You know, the code is essentially running free range, and you don't know what is doing what. And on the other hand, you don't want to have a rigid framework which you cannot escape and rigid layers. So,
but what do you think about that? Because if we like bring ourselves up to date, there's a and this is not something which we've really discussed properly before, but there's a kind of there's a whole waterfall stuff, and then there's the agile stuff, and now there's this movement called developer anarchy. Have you heard of that?
No,
it's true. It's not a joke.
Is it like programming motherfucker thing or something?
No. It's really. There are serious people. I'm not joking. There's actually a guy, Fred George, I think he's called. I think it's Fred George. It's a guy with two names anyway. The notion of developer anarchy is exactly that. Is that actually, if you link your business people and your developer people together, and your developers can do something quickly, will give your developers the freedom to operate and to do things in the way that they want to. Funnily enough, many people choose Clojure in this kind of developer anarchy style thing because it gives them a lot of freedom. But it's all this kind of stuff where people are looking at, well, how do I write something that can be written in like less than 20 lines or less than 100 lines of code, deploy it onto a server, try it out, see if it works for the business, like on a campaign or on a financial site or whatever. And then if it doesn't work out, you know, obviously track some numbers on that thing, see if it works, if everyone's happy with it, that's great, keep it going. Tweak it if necessary, but it's only 100 lines, or 50 lines, or 20 lines, or whatever. So tweak away at it, and then just keep it going. And these kind of things are meant to live for 3 months, 6 months, or a year, or whatever. They're not meant to be 20-year things. So they're all small things. Okay. And that's why this developer anarchy thing is there. I mean, it's like extreme programming. You know, it's a kind of label for giving developers, the actual programmers, more control than people like me who work in enterprise architecture. And I'm a fan of it, actually, because you know, I'm one of the cool dads, you know. And, kids, get out there and do anarchy.
Right Clojure.
Yeah, well, but it's one of these things. It's like, actually, anarchy would be fine, I think, in general, if you could trust all the people. You know,
of course.
And it's kind of like one of these funny things. We're talking about scaling, and of course, anarchy typically The anarchist will tell you it scales, but we haven't seen it in practice, you know. It's like, so anyway, it's a bit of my point anyway is that there's a whole kind of bunch of practices that influence these kind of designs and the scalability. You know, it's not just a code base or a kind of OOP stuff. It's kind of like, well, how quick do you want things to change? How much functions have to be, you know, is it something which you're making for APIs, or is it something which you're making for unknown users? So there's a whole load of parameters, isn't there?
Yeah, of course. And also one of the, because we're talking about the functions and sizes of the code base, then there is always a discussion about, when I was working in a bigger project which has the Angular front end and Clojure back end, and the discussion was, hey, should we add this as a dependency because it seems to be like 40 lines of Clojure? Should we pull in the jar for it, or should we write it ourselves?
Yeah.
So there is always this friction between, is this generic enough to be a library that I can pull in from external code, or so that.
Well, I hit that this week actually, or this week or last week, I can't remember. I've been fiddling with this proxy for Kafka. In Clojure, and I was looking at this. There's a thing called Fast Kafka or something, which is a library for on top of Kafka. It's in Clojure. It's a Clojure sort of library, and you can use it from Clojure very easily. But it has all these built-in things for Redis, and so I think again it's one of these things where if you've got a very large scale problem, applying that framework to it is probably very good. But honestly, it's too much work to adopt it. I just want to write, 20 lines of code, and suddenly I've got this whole thing to grok, and I don't want to do it. And I looked at actually what the Cognitech guys did. I think it was on the Roomkey blog. Maybe it wasn't the Cognitech guys. Maybe it was the Roomkey guys. But whoever, they're obviously that's a big project in Clojure. And what they did was they basically just used the Kafka Java client and just did interop and just coded directly from Clojure directly into the Java. They didn't do exactly what I wanted, but I just followed that pattern actually, and I ended up writing this proxy. Okay, it's not finished yet, but it's quite kind of it's functional. It works. I can transmit server sent events for a topic on Kafka, and it's fast and it's fine, but it's literally 20 lines of code and there's no libraries.
No. Okay.
Well, there are libraries for doing various things, but not for interfacing with Kafka. Yeah.
Okay. Yeah, but that's the advantage with. Of course, you can always fall back to Java pretty quickly, and I think that is one of the advices that I heard some time ago. Like, don't start to make your own things as much as possible. Just use the interop because you're not trying to invent new abstractions on top of it. So
exactly, yeah.
Maybe it was from the Boeing guy's presentation. I think I'm not sure though. I need to look it up.
I think it's in the air actually. I remember hearing that from. I'm pretty sure I heard that on the Cognitect actually. I think it might even have been Craig Andera that said it. Not one of the guests. I think he was talking about his experience because he was saying that he often does this now. And there's obviously a breaking point, once you get to a. Again, this is one of these funny things actually, and it's very slippery actually. It's like you say, it's always a discussion amongst the team. It's where do you move from the Java interop to the library to the framework to the module systems, and I like the fact that there's. I don't like the fact, but I'm open to the fact that there isn't a single answer to that. And actually, all of those things are good. They're all possible, and you want to be aware of all of them and use each of them appropriately. So like you said, I think the big thing is about communication. That's what you said at the beginning about how do you communicate your intent. And I think that's one of the things that we're really coming up with in Clojure actually, isn't it? Is that our goal is to communicate our intent via data actually.
Yeah, and also the newer tools like spec, for example.
Yes.
That's giving us all the niceties of specifying what this function means. And when the code base becomes larger and larger, you don't need to keep all these things in your mind. You can reason about the code easily and then follow the specs.
Yeah, I think spec is really gonna help us a lot in terms of being able to use, again, this data first approach to be able to say, okay, this is what our data looks like. This is what the function is meant to do. This is meant to produce this kind of result. It's meant to take in that kind of shape of data. And honestly, I don't know of any type system that is as powerful as this thing.
Yeah, of course. The type systems are only telling you what is the type of the data, right? They can't tell you what is the shape of the data. And they're not helping you in terms of generative testing, for example, automatically generating the tests and validating them. So it's a kind of a choice, again, as we were talking. I think it has been the theme of this episode. Like you have, at every point, you have a trade-off that you want to make. So I'm making a large application, how I'm going to design my application, and how I'm going to specify the dependencies. And the next question is, okay, the types versus specs. That is a whole different discussion. So there is some dependency typing can solve some of the problems, but I'm not sure how it is going to solve the same problem like specs. So
yeah. Well, the thing, yes, the thing about spec, which is really nice, is all these testing things. You're right.
Yeah.
The other thing we should talk about, like coming back to that though, is how do we expose APIs to each other? And the thing that I've been working on recently is looking at, essentially why are APIs good, but why also are APIs a kind of failure as well? And they're good because, if you want to give people access to a certain set of functions like Google Maps or whatever, then having it as an API is a huge win. So that's excellent. If you want to integrate with Stripe or something, you need an API. So if you want to give people a function to get to grapple with, then obviously an API is fantastic. But often in the corporate world, APIs get in the way, actually. They get in the way of interoperability, and they get in the way of integration. Because people want to write these APIs, they want to make them nice and generic, but they're not like reusable services half the time. And so we're fighting with this concept of reuse in the corporate world, where actually there is very little reuse. Just give the guy the data. Which is why I'm liking these event streams a lot recently, because you can start to put data on event streams and allow different clients to interpret and form different views of that data according to their own needs. And they don't have to hook around and go around to each of individual domains and say, okay, well, what's your API for this product? What's your API for that inventory? What's your API for? No, just give them the product information, give them the inventory information, give them the sales data. Don't make APIs around that stuff.
But did you look into the microservices stuff then? How that fits into the architecture in general?
Yeah, well, we are looking at microservices, absolutely, yeah. And it's always a kind of funny question about what's the difference between a service and a microservice, and it's a total joke. And I was kind of like one of the kind of eyes rolling guys as well at the beginning of this. But I think that there are some specifics around microservice architectures that are interesting, and I think the most important one probably is this discovery thing. Is how if I've got a microservice architecture, well, I've got 20 microservices. So how do I look them up, and how do I make sure that they're all online? They're all available, and what version they are, and all this kind of stuff. And and I think that there's some nice bits of tech around that. So there's this thing called Consul from HashiCorp, which is very nice for registering services and for managing them, and you can get network topologies from it and all this kind of stuff. It really is a very nice thing. And but obviously DNS is the ultimate one of these things. That's a very nice way to do registration. So I don't want to go back to kind of the Corba days of object registrations and all this kind of crap. But
JNDI.
Oh God, yeah. You know something about JNDI, which is it's a bit off topic, this one, but what the hell? I'll just say it. Is that I think if you look at JNDI today, I haven't looked at it for a while, but I looked at it about 4 or 5 years ago. I very much doubt it's changed. Is that the packages? If you look at the packages, the Maven packages for JNDI, there's at least 2 of them which are beta.
Oh.
And they've been like that for about 6 years at the time I looked. So it must be more like 10 years now. So yeah, that got a lot of love. Yeah.
This is a perpetual beta. What's wrong with that? It's a continuously improvement. You know,
it never changed.
It
never changed. It was a continuous beta that never changed. Yeah. But anyway, back to the microservices. So those guys. I mean, you know, the discovery stuff is definitely key, and then there's other stuff which you see the Netflix guys doing is what they call the circuit breaker pattern. Which is, you know, if you can't find a connection to that other application, well, what's your fallback strategy? You know, do you kind of look somewhere else, or do you look to a different service, or do you have some kind of default behavior in you? If that thing, you know, unhappy sort of 404 style thing, which is nice because that means that then, you know, in terms of your architecture and your design, the things that you're thinking about is right. Well, all the stuff that's behind me on the network is essentially fragile, it's essentially unstable, and I need to acknowledge that, which is good. That is a good thing, because there's too much in our industry of pretending that there's a lot of certainty out there. Well, it's true, isn't it? It's laughable. It truly is laughable, you know.
Yeah.
But this is more of acknowledgement that things will break. You know, it's a given now. Things will break. So think about it up front. You know, don't just cross your fingers. You know, so I think that's how ultimately, if we're talking about scaling, those are the kind of thoughts we have to have, isn't it? About how do we actually make things survive failure? You know, and all this kind of stuff. I'm not going to go into all the chaos monkey stuff, but you know, that's all the big data center stuff. But the main thing from a programming perspective is that you need to think in your code. Well, I'm making this call to this service, out to this URL, out to this network thing, and most people's code just says, right, what's next, or exception, meh. You know, there's no
recovery.
There's no recovery. There's no intermediate thinking there. And of course, actually, what's interesting about that is that whole Hystrix thing, that whole layer of circuit breaking, is another kind of friction, if you like, because you know, as soon as you admit that things can fail, then you have to have some kind of framework or some kind of library, or at least some kind of approach that you want to put into place. So I like that, and I'm kind of getting used to what microservices actually mean, and I don't think it really. I mean, microservices, services, blah 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 blah. You know, there's some organizational size stuff that microservices are, but I think the main movement around microservices is just to say, hey, you know, we've got a lot of services on the network that are kind of collaborating, so we need to find them. We need to deal with failure. I think that's really what microservices is turning out to be.
Yeah, I mean, I haven't tried writing any microservices yet, but I'm still waiting for the nano services and Femto or Auto or whatever, and then there is going to be a service that is going to give me bytes every now and then.
Yeah, but they're coming, aren't they? Actually, you know,
the Lambda.
The thing. Lambda, yeah. The Lambda is your nano service, isn't it? But actually, it's even worse than that because you know the Docker thing, they bought this company recently. It's like it's a OCaml company actually. And I can't remember the name now. I will look it up and put it in the show notes. But they bought this company, and this company was basically a Unikernel company.
Okay.
So you're familiar with Unikernels, I guess?
Yeah.
So this was the original Unikernel company from who wrote their own TCP/IP stack and had this Mirage project. I don't know if you've heard of the Mirage project, but just anyway, for the people who haven't heard of it. It's this concept that instead of kind of taking the Linux kernel and putting a container on top of it or a VM on top of it, that what you do is you basically take the bits of the Linux kernel that are necessary for networking or for file system access or for some limited set of process management, and then you compile them together with your application code, and you drop that into the desktop or the application or the web server environment. Put a kind of port out there, and then what's interesting about that is that they did some experiments with it, and what you can do is you can use this services. What's it called? The services daemon where you if you get a call, it starts your program up. What's that called again?
Oh. Anyway,
we'll
look it up.
It's some sort of service daemon anyway in Linux, and what happens is that when you get a request on the web server, there's no web server. In fact, you just get a request on the router, and as soon as that port number gets some ping on it, it starts up the Unikernel process, bootstraps the whole thing, the code runs, it makes the return of the bytes, and it dies.
Oh,
so it's like, instead of like a thread per request, you get a whole machine per request.
Per request, yeah. Okay, that's pretty interesting.
Yeah, but this serverless thing is something which we've found very interesting at work, because I was very taken by this Lambda presentation when it was first done at Amazon, and we got access to the beta during the Christmas after it was announced in the October. And we started playing with it, and it was really great because you could run an event-driven system on the back of these lambdas, and we designed this system for managing requests for information. Okay. So it's turning into quite a big system now. It's called like a customer engagement system. So you can it's a kind of putative CRM actually. But what's interesting about it is that you can start very small just by taking some web forms and managing the kind of reaction to the web forms in an event stream. And then you can start to add integrations. So we have integrations now for Salesforce and for various other kind of sales support activities, and dealers and retailers and all these kind of things. And eventually you get this kind of evolution of these things, and because it's a serverless environment, you're just dropping lambdas in. You just drop more lambdas in. We have a dashboard that shows the progress, but these lambdas, as you add more functions, you don't need to disturb the other lambdas. The actual the continuous integration problem almost goes away because everything that you're doing still stays valid. You just put the extra function on a completely separate infrastructure because there is no infrastructure, and it's actually what I call functions as a service, because that's really what it is.
Yeah. But did you try with the Clojure on Amazon Lambda yet?
I've tried it. Yes,
some people tried,
I've done it, and it all works fine. Yeah, it's we haven't done it at work yet, but I've done it. I've done it both with ClojureScript and with Clojure. And the Clojure one works fine, by the way. I know there's a lot of like talk about the ClojureScript one is faster for the startup and all that kind of stuff. And I think that's kind of true if you're getting a lot of churn. But actually, the way Amazon works is that the Lambda stays around for quite a while. So you don't really.
I need to boot up every time.
If you're not getting much throughput, then I guess there could be some small benefit. But also depends on the problem you're trying to solve. Anyway, but if they both work, and they both work really easily, actually. You just uberjar it and off you go. You just write that one bit of code. In fact, I think the USwitch guys made a little demo. That's what I used. They made a little demo wrapper around the Java thing, and it's literally 5 lines. So, bam, off you go, and it works really well. Yeah. So Clojure. I mean, honestly, maybe we're coming back to this kind of scaling things, because like you were saying before, we keep on nodding, we keep on sort of tapping each other on the shoulder and say, an hour's nearly up, and I think it is already. So we probably should start to wrap this up now.
Yeah, of course. I mean, so anyway, coming back to I think we have started from all the way, and then we went to the lambdas now.
Yes.
So my current toolkit, or at least the new project that I started last week. So right now my toolkit is essentially, I never tried component, but I'm planning to use mount this time.
Okay.
And then see how it is going to go out. And obviously I'm going to use spec for this one. So I'll report back what I find, and it'll be fun, I think.
Definitely, yeah. Just before we go with the component mount discussion, I had a discussion. Actually, it was with Hoplon, the Hoplon guys. Misha wasn't involved in this discussion, although the guy who I was talking to was saying that this is what Misha tells us, is that actually all these component frameworks and mount and stuff like that, injections and all these kind of things, are doing the wrong thing, and you should basically explicitly pass in database handles and server handles and all these kind of things into the functions, and not hide them behind these component systems. So what do you think about that?
Yeah, I mean, there is always this is the standard discussion about dependency injection, good or bad, and because that when I started writing a program in Scala some time ago with Akai actors, and we had the similar discussion about the design choices, like should we use injection or should we just pass all the things like a builder pattern, just pass the whole thing. And I think we ended up passing the whole stuff, because then each function becomes a function. It's not dependent on external crap.
Right.
So that's why I didn't even component is not actually a complete dependency injection. It's not a runtime dependency injection. You still need to specify this is what I need, so that needs to be passed around. So I'm kind of in between, I would say. So I'm gonna write down a reasonably big program to see how it feels, and then decide, okay, then screw it, I'm going to remove the component and then just go ahead with passing the functions around. So no direct answer, no yes or no.
Yeah, and I think the argument typically is, isn't it, that like you say, you can the transparency of the dependencies is right there in your face, and there's no magic, so that when you come to run this thing, you're not sort of suddenly, didn't read the documentation about this needing a database or a Redis or a blah blah blah. Incidentally, just as a final little aside here, is that one of the things that I have looked at over the last couple of years is Heroku, and they have this thing where you can now say they have a little what they call it's like a Node.js file. It's not the properties one. It's
build pack or something.
It's like a build pack, but it's a dependencies. So it's a bit like an npm file. But what you say is, rather than having a module that you depend on, you can say that it's a service you depend on. So it's a bit like this kind of like behind Docker or behind these kind of orchestration engines. So they have this thing where you can say, okay, I require this add-on, I require this service, and then it can be bootstrapped. So that's another kind of interesting modular approach, if you like, is that you want to be able to express in data what your dependencies are and be explicit about that.
Yeah.
Anyway,
so we should wrap up, I think. So in conclusion, my tool set right now, go with the functions and then use specs and try out component or mount, essentially mount this time. And I think the scaling is essentially depending on how you approach, and there is it's still an open question, and we know there is a lot of code out there, like Circle CI guys building large Clojure programs, and obviously there is Datomic. I don't know how much of Datomic is written in Clojure though. It will be interesting to see, but I think that's it from that's it for us for today. I think we should wrap up with a quick overview. So we're going to post the show notes on Defn Audio, and obviously the episodes will be on. Maybe you're listening to it already on iTunes, so tell your friends and their friends.
Leave a review, actually. That would be quite nice. I haven't seen the reviews. I must write a review myself, but how awesome it is.
Yeah.
But it would be nice to get a few reviews, because that helps to spread the word as well, I think.
Exactly. And if you have any nice ideas that we should focus on, or guests that we should invite, please let us know. We'd love to invite them onto the world's best vegetarian Clojure podcast. That's a privilege, obviously. And anything else? Oh, of course, we'd like to thank Pizzeri for the intro and outro music, and you can find more of his music on SoundCloud under Melon Hamburger.
Yeah, that's right. So it's been good. Yeah, thanks very much. I hopefully not too much. Well, there's quite a bit of villagidgery going on in this episode. We'll be back to getting a guest to keep you a bit more amused next time. Yeah. Or maybe it's more, you could be amused on this one and more educated on the next one. Yeah.
So this is the comic relief every now and then.
Exactly, yes.
Okay.
All right, mate.
That's it from us. Yeah. Bye-bye.
Bye.